Hello, everyone, and a very good evening to you all. So, in this video, I'll be explaining how to accurately read the Vernier Caliper and the micrometer screw gauge. So, let's get into it. So, before we actually start answering any questions, I just want to explain what the Vernier Caliper and the micrometer screw gauge actually are. The Vernier caliper and the micrometer screw gauge are instruments that are used to measure length in physics. So, the Vernier caliper, this is an example of a Vernier caliper, how the questions look like. I don't actually have an image stored on my system, but you can use Google to browse how a Vernier caliper actually looks like. So the Vernier caliper has a reading accuracy of 0.01 centimeters. Let me just write that down here. 0.01, sorry, centimeters. While it has a zero point 0.1 millimeter reading accuracy. Now, the Vernier caliper is used to measure um, objects that have extremely small lengths. For example, the internal and external diameters of a tube, the thickness of a meter rule, or the diameter of a rod. So that's basically what the Vernier caliper is all about. So, without further ado, let's try to solve these two questions that we have in front of us. So the first step of reading the a Vernier caliper is understanding the two types of scales we have. So in the Vernier caliper we have two scales. We have the main scale, which I will highlight in red, or circle in red rather. I don't think that's correct. So I'm take it again. This is the main scale, and the one highlighted in blue is the Vernier scale. This mini one down here. So the main scale is going to be like the main number. You document it just as it is, like as it's a whole number. But the Vernier scale actually depends on the units that we want to write our final answer. So assuming our final answer unit is in centimeters, we would write our final answer. If maybe our Vernier scale reading was 5, we would say the Vernier scale reading was 0.05. But if our final answer should be in millimeter, our Vernier scale reading wouldn't be 0.05, it would be 0.5. So just for today's class, or for these questions rather, I will take the final answer of these questions to be in millimeter. Okay, so we first have to read our main scale. So our main scale is this big one up here, not this mini one. The mini one is the Vernier scale. The big one up here is the main scale. So how do we read the main scale? Well, basically, you count from the left hand side all the way to the right and stop at the point where the Vernier scale stops. So the Vernier scale stops here. So let me just draw a red line up. I'm sorry, let me use an actual straight line. So this is where it stops, right? Now, so that means this is what we're going to, sorry, let me change back to a marker. So that means from here to here is what we're going to read. Let me draw that again. From here to here is what we're going to read. We're stopping here. That means we're not extending further up to the number 4 here. We're stopping at the point at which the Vernier scale connects with the main scale. So that means, let's count together. This is 2. Each mini dash stands for 0.1. So 2 plus 0.1, 2.1. So 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8. So we're going to stop at 2.8. So that means our main scale reading is 2.8. So let me just write that here. Sorry. Our main scale reading is 2.8. Now, we've gotten our main scale reading to be 2.8. We still have our Vernier scale to read. So let's read that together, or let me explain how you read the Vernier scale. So the Vernier scale is also depends on the point at which the Vernier scale lines actually connect with the main scale. So when we're reading the main scale, we stopped at the point in which the main scale connects with the Vernier scale, which was here, right? Now, for the Vernier scale, we stop at the point in which one of its lines, this reading lines, this let me just say, it kind of looks like a meter rule. So let me just say meter rule lines connects with the main scale lines, and this one obviously doesn't connect with this line or this line, so we're not going to use it. This one doesn't connect with this one or this one, so we're not going to use it. This one, look at it, doesn't connect with this one or this one. This one, sorry, this one doesn't connect with this one or this one. This one, this is the best line. This is the best line because it connects the most with the main scale line. If we were to draw a highlights in marker over it, we can see that this one connects the best with the main scale line. Read the we stop reading the Vernier scale, or we stop counting the Vernier scale the moment it has a line that connects perfectly with the main scale line. For example, this line is perfect. This line too connects, but we're taking the first line that connects, which is this one. So this is the line we're going to stop counting at. Now, what do I mean by the line we're going to stop counting at? Remember, we stopped the main scale reading at 2.8, which was here. Why? Because it was at this point that the Vernier scale was the Vernier scale connected with the main scale. Now the same goes for this one. This is the line that the Vernier scale connects with the main scale line. So now let's count: 0, 1, 2, 3, 4, 5, 6. So this is 6. But we're not going to say 6. Why? Remember, I mentioned at the start that if it's measured in the reading of the Vernier scale depends on the unit we use, if it's centimeter or millimeter. Since we're using millimeter, this isn't going to be 6. Instead, it's going to be 0.6. So we're going to have another text. I'm going to say Vernier scale reading is 0.6. Now, how are we supposed to get the total reading? Very simple. We're going to say the main plus the Vernier scale. And what's that going to be? That's going to be 2.8 plus 0.6. So that should give you 3.5 millimeter. So that's our point. So let's take a look at the second question. So the second question, we're also going to do the same thing as we did for the first one. We're going to count the main scale first. So let me get this, or this rather. So this is 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8. Now, we'll start at 2.8 again because that is the point at which the main scale and Vernier scale connect or touch. So that's it, 2.8. It stopped just after 2.8, so that's what we're going to use. Now, let's write that down. Mm, 2.8. Now, now it's time to read the Vernier scale. Now, using the same method as we did here, we're going to count 1, 2, 3, 4, 5. Remember, as you're counting, you're going to stop at the line that connects the most with the line of the main scale. So let's start again. 1. 1 isn't connecting with any of the lines. 2 isn't also connecting with any of the lines above it. 3 is not really matching any of the lines above it. 4 is also not connecting with any of the lines above it. 5 is not connecting with any of the lines above it. 6 is matching correctly, but so is 7, 8, 9, and even 10 actually. Which of these lines are we going to use? That's very simple. We're going to use the first line that connects. And what's the first line? 6. So that means our Vernier scale reading is going to be what? 6. So let's write that down. Sorry, it's not going to be 6. It's going to be 0.6 since we decided to measure in millimeter. If it were in centimeter, it would have been 0.06. Now, how do we get the final answer? Very simple. We see 2.8 plus 0.6, which is actually the same as what we had here. So our final answer is still going to be 3.4 millimeter. Question that we're going to take. Now, let's take a look at it. This is 6. The question is just not that clear, but this is 6. This is 7. Now, what was our first step? Reading the mean scale. So now, and when we read the main scale, where are we going to stop? We're going to stop at the point that the Vernier scale matches with the main scale, and that is here. So let me just draw a line to show that this is it. So we're going to stop before, we're going to count all the lines before it hits this spot, not after, before. So let's count. 6, 6.1, 6.2. We're not counting any further because this is the point at which the main scale and the Vernier scale meet. So our main scale reading is 6.2. So let's write that down. Mean scale 6.2. Now, what was our next step? Reading the Vernier scale, right? Right. Now, let's take a look at it. Which line of the Vernier scale perfectly touches the line of the mean scale? Let's take a look. Let me use this. So we have 0, 1, 2, 3, 4, 5. All these lines are not touching the lines above it. This one has no connection with any of these lines. Neither does this one, or this one, or this one, or this one, or even this one, this one. This one is close, but let's keep checking whether we see one that's even closer. We found it. This one. This one is so perfectly straight. So this is what we're going to use. Now let's count again from the beginning. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means our Vernier scale reading is 9. Now let's look at the questions. What was the unit they used here? Centimeter. And what did I say about the units? If the unit was in centimeter, what are we going to use? We're going to use 0.01. This is the format to follow. 0.0. I say 0.0x. Now, if it were in millimeter, it would have been 0.1 millimeter or 0. X millimeter. For our reading is in centimeter, so we're going to read it in centimeter, meaning that our 9 here is not actually 9, it is 0.09 centimeter. So let's write that down. Vernier scale 0.9. Now, how do we write down our final answer? What's our final answer? It's very simple. We just add the mean and the vernier. And what is that going to give us? Mean plus vernier is going to give you 6. Sorry, it's not supposed to be 0.9. 0.09. My bad. Mean plus vernier, which is going to be 6.2 plus 0.9, 0.09, and that is going to give you 6.29. Very simple, honestly. Centimeter. Don't forget your units. So now let's look at our answer and compare what's in the options. What do we see? Final answer is E, 6.29 centimeter. So I hope this topic, Vernier scale, was um, explanative enough for you to understand it. If you found it useful, please like and subscribe, and also drop your comments below if you have anything you're confused on. Thank you very much for watching the video, and see you next time. So for the micrometer screw gauge video, I will link the video down in the description because I did not explain it here because of how long this video was. Thank you.